there folks, Mr. G again, back with another educational video. This is part 3 of our special triangles, and in this part we're going to be going over how to solve the types of questions you're going to see in the workbook. So the first type you're going to see are questions that are just going to ask you to evaluate the cosine or sine or tan of a certain angle. Now if it's less than 90 degrees, you can do this pretty easily by just looking at the table or by drawing out your special triangles. But if it's bigger than 90 degrees, we're going to need to do a little bit more work. If you remember from our discussion, the important thing to do for this is to find a reference angle. So this is going to be equal to either plus or minus the cos of the reference angle for 210 degrees. And this plus or minus is going to depend on which quadrant we're in. To help us figure out the reference angle and the quadrant, let's draw this. So if our angle is 210 degrees, it's going to be about a little bit bigger than 180. So it'll be somewhere along here. If this is 180, this is 210, this angle between these two needs to be equal to 30 degrees. Now, if this was in a classroom where you would be having tests, I wouldn't be giving you the table of values for, what's cosine of 30, what's sine of 60, what's tan of 45 degrees. You would either need to memorize that or be able to reproduce the diagrams. So just have that in the back of your mind, and when you're doing these types of problems, I encourage you to try and do them without looking at a table, to either try and reproduce the triangles or to memorize them. So in this case, we can see that our reference angle is going to be 30 degrees, so our answer is going to be plus or minus the cos of whatever 30 degrees is. We can figure out the sine of this by using our add sugar to coffee. We're in quadrant 3, only tangent is positive. That tells us this cosine is going to be negative. And whether you memorize it or reproduce the diagram, cosine of 30 degrees is root 3 over 2. So we get our answer of negative root 3 over 2. Let's do one more example, tan of 300 degrees. Again, we're going to need to find the reference angle in the quadrant, so let's draw it out. 300 is a little bit bigger than 270. It's in fact 30 degrees bigger, so this angle right here is 30 degrees. But be careful, that is not our reference angle. Remember, the reference angle is the angle between our terminal side and the x-axis. So this right here would be our reference angle, which would be 60 degrees. That's because this whole quarter turn here is 90. If this is 30, this needs to be 60. So our answer is either going to be plus or minus tan of 60 degrees. Using add sugar to coffee, we can see that only cosine is positive in quadrant 3, so our tangent is also going to be negative. And whether you memorize the table or can draw it out, you can figure out that tan of 60 degrees is equal to negative root 3. And there's your answer. Both of these examples told you what the angle was and wanted you to figure out the value of the trig function. The other types of questions have you do it in reverse. Those types of questions will ask you something like, find all angles between 0 and 360 degrees such that cosine of theta is equal to negative root 2 over 2. The first thing we want to think about is where can cosine be a negative number? So looking back at our add sugar to coffee, we can see that cosine is positive on these two quadrants, 1 and 4, so it's negative in quadrants 2 and 3. So now we know where our angle is going to show up. Now we want to know the size of the angle, and in this case we're going to use the same thing that we did in our previous examples in reverse. So in this case we want to find the reference angle. To find the reference angle, we want to know the size of cosine of theta, where we ignore the sine. So we're going to forget about this negative sign and just think about when cos theta is equal to root 2 over 2. Basically what we're doing is we're doing the last step of our previous question in reverse. So we're going to ignore the signs for now and just think about if it's root 3 over 2, what's the reference angle? In our previous case it was 30 degrees. So if the cosine of our reference angle is root 2 over 2, what's our reference angle in this case? Well, we would need to again remember back to our special triangles, whether you memorized it or redrew them. And remember that the reference angle, if cosine is root 2 over 2, is going to be equal to 45 degrees. So we have two possibilities. Either we're in quadrant 2 with a reference angle of 45 degrees, or we're in quadrant 3 with a reference angle of 45 degrees. Now we want to know what the actual angle is, so we need to look at what the total angle between our initial side and our terminal side is. In this case, our total is 180 degrees for this half turn. If it's 45 degrees here, this green side would have to be 180 minus 45, which is 135 degrees. For our second diagram, it's 45 degrees larger than 180, so our answer would be 180 plus 45 degrees, which is 225 degrees. And those are our two answers. 135 and 225 degrees will give us a cosine equal to negative root 2 over 2. Our next example involves a trig ratio with a value that is actually a decimal, not an exact value. We started off in a similar way where we want to think about where tangent is positive in this case. Add sugar to coffee, we can see that tangent is going to be positive in quadrant 1 and quadrant 3. Now, if you remember back to when you did trig last year, if I told you the tan or sine or cos of an angle, there was a way you could figure out the angle itself, and that was by entering this inverse tangent function. This would be something you plug in on your calculator. If you don't have a scientific calculator at home with you, there are ones available online. I just searched up scientific calculator and this is what came up for me. And as you can see, it's got our inverse tan, it's got all of the other buttons that we need here. It's really important that it's in degree mode because we're just dealing with degrees here. You'll talk about radians in grade 12. To enter this, we would do tan inverse of 2.189. And in this case, it's calculating out for us 65.44767 blah, blah, blah. So we have the value of theta in this case, and this is going to tell us our reference angle. Again, I encourage you to keep 3 extra decimal places just so that you have no rounding errors. Once we have our reference angle and we know it's in quadrant 1 or quadrant 3, we can draw out our picture and figure out our answer. Here's our 2 possibilities. For our first one, it's really simple. To 1 decimal place, it's just 65.4 degrees, since our reference angle is equal to our angle. For quadrant 3, we have to add our reference angle to 180. We get our answer of 245.4 degrees. Those are our 2 answers for this. Our last example is also going to be a decimal, this time negative. First, let's figure out where sine is going to be negative. It's positive in quadrant 1 and 2, so we're going to be looking in quadrants 3 and 4 where sine is negative. The next thing we want to do is find the reference angle, and we're going to be using our inverse sine, just like inverse tangent of our value here. But in this case, we're just going to be using the size of this. We're going to ignore the negative sign. Very similar to how we ignored the negative sign in part A when we were figuring out our reference angle. For our reference angle, we only cared about the size, not the sign of cosine. For our first decimal question, it was already positive, so we didn't have to worry. For this one, we're going to be taking the positive value of our sine theta here. And that's going to tell us our reference angle. If we punch that into our favorite scientific calculator, we get a value of about 12.6 degrees. This is our reference angle, so we need to draw out the 2 different places where it could be in quadrant 3 or quadrant 4, like so here. In our first case, it's 12.5916 degrees bigger than 180, so we get 192.6 degrees. For our second example, we're this many degrees short of 360, which gives us 347.4 degrees. And those are our 2 answers. That's the end of the video here. Take a look at some of the homework questions, try some of them out, and I'll see you in the next video.